Good afternoon and happy Friday. Today I was going to show you, I guess I should go to the page, sorry. First of all, the homework answers. So here they are. Most of us got all of them right except for 17. There was one mistake. So look here and see if you can figure those out. And then I was just going to show you one new type of word problem today so you could kind of see a little variation in what some word problems might look like. And then I was going to have you try 3, 4, and 5 that are just like what we did yesterday and the day before. So just like these word problems here, and then the ones from the day prior. So I'm going to let you do 3, 4, and 5, and I'm going to do 1 and 2 with you. Okay, so it says, if a child pulls a sled through the snow with a force of 50 newtons exerted at an angle of 38 degrees above the horizontal, find the horizontal and vertical components. So let's first break down what it's asking. So it's asking for the horizontal, so like this, and then the vertical would be like that, components. Now that word should sound familiar to you because that's something that we've talked about before. So do y'all remember component form is like the pointy parentheses with the, comma between them, like an ordered pair, essentially? This is kind of like your X and this is kind of like your Y. Not kind of, it is. So this will tell you, the X will tell you how far to the right or to the left to go, and then the Y will tell you up and down. So the reason that this problem and the next problem are a little different from the ones that we've done thus far is that we don't have 2 vectors in this problem, like acting on an object or anything. We just have 1 vector. So we have the child pulling the sled. So it's an angle of 38 degrees above the horizontal. So first of all, I'm going to draw the horizontal like this. And then I'm going to go about 38. That's too much. Okay, so that would be 38 degrees. And the force exerted is 50 newtons. Now, can y'all see that this, if we were to drop a perpendicular or an altitude like so, like this, what kind of triangle does that make? It makes a right triangle. So the reason that this problem is slightly different from the previous ones is because instead of having an oblique or non-right triangle, we now have a right triangle. So we're trying to find this X and this Y, the vertical and the horizontal and vertical components of this vector. And so I hope that kind of looks familiar to you. So my question is, should we use law of sine, law of cosine? And the answer is no, because we only have one side and one angle. I guess technically we do have another angle here. So technically we could do law of sine because it's angle, angle, side. But let's try to think a little smarter it's not necessarily smarter. It's just to kind of fall back on things that we already know. And it's a little easier, in my opinion. It's faster. So if we have a right triangle, because this is a right triangle, do y'all agree or remember? I guess you kind of have to agree. But do y'all remember we can use SOHCAHTOA when we have a right triangle? And that's what we're going to do here. So let's pretend that the Y is not present. Okay, we just want one variable for right now. Okay, so according to this 38, the X would be labeled A and the 50 would be labeled H. And so which trig function would we use? Well, that is cosine. So we can do cosine 38 degrees equals A over H. And then if you remember, that's a multiply problem because the X is in the numerator. And then we can just type that right into our calculator. So 50 times, I was about to put sine, cosine 38, and you should get, does it say how to round? I did not put that in the directions, sorry. So let's do, X is approximately 39.4 units, okay? So there's our X component. Now we're going to do the same thing. We're going to pretend like the X doesn't exist, and so now I'm going to go and erase this and put the Y back. Okay, and so now what does the y get labeled? According to the 38, it gets labeled O. And so then for the y, we're going to do sine. And that should make sense, right? Because y with like the unit circle goes with y, sine goes with y, and cosine goes with x. So that's kind of a, relationship we've talked about a lot in the class. And so then we're going to multiply. And so then 50 times sine 38 degrees is 30.8. And then the unit would be newtons. Okay? So there's our answer. So I just wanted to show you that we can do vector word problems with just one vector, and that would be where you're going to typically have a right triangle, because you're going to have it in relation to the horizontal. So it'll force a right triangle to occur. If we have two vectors acting on a force, typically it will be not a right triangle, and so we'll use the law of cosine. All right, let's see what number 2 presents to us. You are on a jet plane that takes off from JFK. Its velocity is 400 miles per hour due east. Okay, so let's first remind each other, because that's going to be important here. North and south, everybody's pretty good at. Now, east and west, I don't know about y'all, but when I learned it, I learned to spell the word we. Or did y'all learn never eat soggy waffles? That's the order that it goes if you want to say that. So I just always remembered north-south goes in that, that's pretty easy. But then west to east spells the word we. All right, so due east means that we're going to draw a vector. Sorry, I'm being very indecisive with the colors. Perfectly horizontal. Due east means like perfectly east. Okay, so 400 miles per hour goes here. There is a wind blowing with a velocity of 160 miles per hour from the south. Okay, so if it's coming from the south, what does that mean it's really blowing towards? So if it's coming from the south, we're going actually north, okay? So from the south means we're going north. So there are two ways you could draw this. You could draw it like this, right? Actually, not two ways. You could draw it a number of ways. So you could draw it like this, you could draw it like this, or like this. Now, let's be smart about how to draw this. I think most students would probably draw it like this or like this, if I had to guess. Now, let's see which one makes the most sense. Okay, let me back up. Does everybody see that this is two vectors? Okay, so we have to decide, is this going to be a right triangle or not a right triangle? Maybe you can tell, but I think hopefully you can, that if we're going due south and then north, that actually is going to create a right triangle, a perfect right triangle. See it right here? Okay. Now, the only problem with this is if we had the two vectors like this and we want to find the magnitude and the direction of the resultant, so that's what we're looking for. Do y'all understand we have to have it tip to tail? And is this, or are these two tip to tail as they are? And the answer is no. They're both tail to tail. So we want to make it go like this. Now do you see that that is tip to tail? Okay? All right, so hopefully that makes a little bit of sense, that we really should draw it. And you could have left it the way we had it originally if I were to go back like that, but then you'd have to slide it. So, that's also okay. So let's put it back like we have it here. And now we can draw the resultant that is here. And that's what we're going to look for. And this is what we're going to look for. But, so, okay, let's go back. Because it is like the other problems we've been working on, maybe you want to do the law of cosine because you have a side, an angle, and a side. The short answer is yes, you can absolutely do that if you want. But again, because we have a right triangle, it might be easier to do SOHCAHTOA. I just think it is. It's a little less typing in the calculator. Okay? Now, actually, there's another way we can do this problem without SOHCAHTOA. remember Pythagorean theorem, that can help us find the hypotenuse. Okay, so again, I'm kind of showing you all these different possibilities. I know it might seem like a little overwhelming, but I just wanted to open it up to you. So let's do Pythagorean theorem. I think it'll be easy. So 400 squared plus 160 squared equals c squared. So those are big numbers. Let's type them in. 400 squared plus 160 squared gives us, and I have no idea if that's a perfect square. Let's see if it is. The answer is no. So we're going to round it when we take the square root, and it's going to be 430.8. Okay? So 430.8 miles per hour. Now, just because I want to show you that you actually can do it the other way, so I'm going to do it. This was Pythagorean theorem. I'm also going to do it law of cosine. Okay? So law of cosine would go 400 squared plus 160 squared minus 2 times 400, 160, and then the cosine of the angle between it, which is 90 degrees. Okay? Now, all of this is actually going to go to 0. And the reason is if you think about the unit circle, the cosine at 90 degrees is 0. So 0 times all of those numbers will give you 0, which will leave this, which is the same thing as Pythagorean theorem. Okay? But if you didn't know that, that is totally okay. You can just type it into the calculator. You'll get the same thing. So then that would be x squared would equal that same number as up top, and then you would get approximately the same thing. Okay? So, Pythagorean theorem, law of cosine. You decide which one you like. Maybe some of you are like, I don't want to try to decide if it's a right triangle or not. I just want to stick to the law of cosine. That is totally fine. Okay? All right, and now we have to find a theta. So again, you can do law of cosine and do 430.8 squared plus 400 squared minus 160 squared all over 2 times 430.8 and 400. I'm going to choose to do SOHCAHTOA, and you can choose to do it with any two numbers. Now, I'm going to ignore the 430.8 because in case I made a mistake. So this is my O and this is my A. So I'm going to do tangent. So I'm going to do tangent theta equals O over A. But do y'all agree you technically could use any of the SOHCAHTOA and use 430.8 if you wanted to? And then this is where you type in second tan, remember? And do 160 divided by 400. And then you should get approximately 21.8 degrees. Okay? And just for fun, I'm going to type it in the other way. All right, so when I typed it in using the law of cosine, so I did like 430 squared plus 400 squared, all that stuff, I still got the exact same answer. Okay, so either way you want to do it, you certainly can. So did we answer the question? It asked for the magnitude and the direction. So we found the magnitude. Here's the magnitude, and here's the direction. Okay? All right, I'm going to erase this so it gets out of the way, but I just wanted y'all have it so you can rewind if you need to go back and see. I'm just going to talk through these last three so you can, make sure you understand what's going on. So on number 3, you're finding the magnitude and direction. It is going to be similar to Wednesday's problems, okay? Because you have two vectors, and I'll just go ahead and tell you it's not going to be a right triangle. That is clear, okay? Number 4 is like yesterday's problems. We have two forces on an object. Oh no, I take that back. We have all three. Okay, so this one's slightly different. I want to see if y'all can come up with this one though. You're going to be finding the angle between two of the forces. Please make sure on all three of these, okay, it is tip to tail when you draw. Okay, because you're going to be dealing with the resultant. And then you're going to find the magnitude just the magnitude in the last one. Okay, so the number 3, you're finding the magnitude and direction, both. Number 4, you're just finding an angle. And number 5, you're just finding a magnitude. So this one is direction only. And this one is magnitude only. Okay, so try your best. I will go ahead and tell you they are more like what we did yesterday and the day before than what I showed you today. But I just wanted to open you up to yet another type of word problem. Okay, so that's that. We will go over those 3 on Monday and continue to practice with the word problems. And then we'll be wrapping up vectors probably by the middle of next week. All right, y'all have a great weekend.